We will be demonstrating object-oriented programming with C# using a console application. Create a new class named Square. The public accessor allows the class to be accessed by other classes. The namespace is used to group related code. A property is used to store data in a class. The side dimension of the square will be stored in this property as an integer. An object is an instance of a class. Here we create an object from the square class called smallSquare. The using statement is used to add the namespace that references the square class. We use the new keyword to instantiate an object from a class. We set the side property of the smallSquare object to 1 using the dot operator. We get the side property of the smallSquare object using the dot operator and write the value in the console window. Run the application. The side property of the smallSquare object is written in the console window. A constructor is a special method with the same name as the class. It runs first when an object is instantiated. In the square class, when the constructor runs, it sets the side property of the object from the parameter provided. We instantiate an object called smallSquare and pass in an argument of 1 in the constructor. The constructor will run and set the side property of the smallSquare object to 1. We get the side property of the smallSquare object and write it in the console window. Run the application. The side property of the smallSquare object is written in the console window. A method executes a function in a class. The method called calculateBaseArea calculates the area of the square. It takes no parameters and returns a value that is an integer. We instantiate an object called smallSquare and use the constructor to set the side property to 5. We then call the calculateBaseArea method on the object and store the area of the smallSquare object in a variable called area. We write the side property of the smallSquare object and its area in the console window. Run the application. The side property and area of the smallSquare object is written in the console window. The rectangle class has 2 properties, length and width, a constructor and a method to calculate base area. Inheritance extends or modifies the behavior of an existing class. The cuboid class inherits from the rectangle class. It has a property named height and inherits the length and width properties from the rectangle class. This is the base constructor from the rectangle class. The cuboid class must implement the base constructor from the rectangle class. It then extends its constructor to include the height parameter. The cuboid class has a method to calculate the volume of the cuboid. We create a small cuboid object and set the inherited length and width and the height in the constructor. We call the inherited base method on the small cuboid object to calculate the area, and we call the method to calculate the volume. We write the dimensions of the small cuboid object in the console window. We also write the area and volume. Run the application. The dimensions, area, and volume of the cuboid is written in the console window. Method overloading in C# allows a class to have multiple methods with the same name, as long as their parameters are different. The shape class has 2 methods with the same name called calculateArea with the same return type. But each method takes different parameters and perform functions differently. We say the calculateArea method has 2 overloads. The square class and the rectangle class both inherit from the shape class. We create an object called square. We call the first method overload to calculate the area. We create an object called rectangle. We call the second method overload to calculate the area of the rectangle. We write the areas of the square and rectangle in the console window. Run the application. The areas of the square and rectangle are written in the console window. Method overriding allows a child class to provide a specific implementation of a method that is already defined in its parent class. The shape class is the parent class and has a virtual method called calculateArea. The virtual keyword allows this method to be overridden. The circle class inherits from the shape class and is called the child class. The circle class overrides the calculateArea method from the parent class. It implements a function to calculate the area of a circle. We create a circle object. We call the overridden method on the circle object to calculate the area. We write the area of the circle in the console window. Run the application. The area of the circle is written in the console window. A static class cannot be instantiated. Instead, you access its methods or properties directly by using the class name itself. The shape-type class is a static class. There are two static methods. One returns a string for square, and the other returns a string for circle. We call the getCircle method directly from the shape-type class itself. Notice how we did not have to instantiate an object first. We then write the return string from the method in the console window. Run the application. The shape type is displayed in the console window. An interface is a contract or a blueprint for a class. iShape is an interface. It contains signatures for a property called xDimension and a method named calculateArea. The calculateArea method does not have an implementation. The square class inherits from the iShape interface. It provides implementations for the members of the interface. The square class provides an implementation for the calculateArea method to calculate the area of a square. The circle class also inherits from the iShape interface. It also provides implementations for the members of the interface. The method calculates the area of a circle. We create a circle and a square object. We set the xDimension for the circle and square objects. Then we calculate the area for the square and circle objects. Finally, we write the value of the areas in the console window. Run the application. The areas are written in the console window. An abstract class is a special type of class that cannot be instantiated on its own. It contains members that can be reused by other classes. ShapeBase is an abstract class. It contains a property called xDimension and a method to convert the dimension to metric. The circle and square classes both inherit from the ShapeBase abstract class. We create a circle object and a square object. We set the xDimension for the objects. We call the inherited convert to metric abstract method on the circle and square objects. Finally, we write the values of the dimensions in the console window. Run the application. The dimensions are written in the console window. We will use what we learnt in object-oriented programming to build a sample console application. A painter paints signs on a rectangle and ellipse-shaped surface. His fees are based on the area of the sign. We need to write a console application to calculate the area of the sign. The application must display the dimensions of the sign and its area in imperial or metric units if required. The iShape interface contains the signatures for the properties, xDimension and yDimension for the sign. It also contains an isMetric property to determine if metric conversion is required. The interface contains a signature for a method to convert the dimensions of the sign to metric and one to calculate the area of the sign. The rectangle class inherits from the iShape class and must provide implementations for members of the interface. For the properties, it inherits from the shape-base-abstract class, which provides the implementation for the properties. It also provides an implementation for converting the dimensions to metric by inheriting the method from the shape-base-abstract class. The rectangle class provides its own implementation to calculate the area of a rectangle. In a similar way, the ellipse class inherits from the iShape interface and calculates the area of an ellipse. It provides implementations for the properties and metric conversion of the interface by inheriting those from the shape-base-abstract class. Notice how the shape-base-abstract class provides reusable members for both the rectangle and ellipse class to use. We create an enum called shapeType to provide us with a list of constants for the shapes. The ShapeFactory class will create a shape based on the shapeType parameter we select. Notice how the return parameter for the create method is of type iShape. In this way, it can return an object for any class that inherits from the iShape interface. Remember, the rectangle and ellipse classes both inherit from the iShape interface. Now we can start building the user interface. For simplicity, we will disable nullability and forego validation checks on user input. We set a display header for the application. We get the shape type for the sign from the user. We set the shape type for the enum by reading the user input in the console window. We use the ShapeFactory class to create the shape based on the shape type selected by the user. We get the X dimension and Y dimension for the sign from the user. We get if metric conversion is required from the user. And convert the dimension if necessary. We calculate the area of the sign and set the units. Finally, we output the dimensions and area of the sign to the user. Run the application. Select the shape type. Enter the dimensions. Select if metric conversion is required. The shape, dimensions, and area of the sign are displayed to the user.